planet-shaped planetary nebulae, the spectacular results which take place in a sun-like star's life have intrigued astronomers for years. A planetary nebula is a huge shell of gas expanding away from a tiny but exceedingly hot central star. This exposed core of the star emits intense ultraviolet radiation that charges the gas in the expanding shell, causing it to glow brightly. One of the closest planetary nebula to our solar system is the Helix Nebula. Located in the southern sky in the constellation Aquarius, it is a popular target of amateur astronomers. It can be seen even through binoculars. Larger ground-based telescopes revealed spoke-like features on the inner edge of the ring. In 1996, the Hubble Space Telescope observed a portion of the Helix Nebula and captured a detailed image of the remarkable finger-shaped objects known as cometary knots within the inner edge of the disk. Each of these cometary knots has a bright head and a faint nebulous tail streaming away from the central star. These cometary-like features were believed to be material that was fragmented from the dying star and compressed and trapped into these tiny knots.
What we see when we look with the Hubble Space Telescope is that some mechanism has operated to trap about 1/2 of all of the material that's been ejected by the star into these tiny knots, which are just a few times the size of the solar system. An entirely unexpected result.
The Hubble Space Telescope returned to the Helix in 2002 when the Leonid meteor shower crossed Earth's path. To protect Hubble's mirror, the telescope was pointed away from the meteor stream. Astronomers used this as an opportunity to view the Helix Nebula, which was almost exactly in the opposite direction of the meteor stream. To capture the sprawling nebula, Hubble took 9 separate images using the new Advanced Camera for Surveys as it waited out the storm. Astronomers at the Space Telescope Science Institute assembled these images into a mosaic. To fill in the missing elements, the scientific team then blended the mosaic image with a wider image taken by the mosaic camera on the National Science Foundation's 0.9-meter telescope at Kitt Peak National Observatory near Tucson, Arizona. This breathtakingly beautiful image of the helix revealed wonderful clarity of the cometary knots embedded in the colorful red and blue gas ring.
So the cometary knots in the helix point towards the central star which created them. And this happens in a 2-step process. The first step is a shock. And the shock is like pressures in the Earth's crust which creates higher density rock and it creates higher concentrations of gas in the nebula. And the second step is the radiation. The radiation is like rain on the Earth, which trickles down and removes all the loose stuff around, and it reveals the hardened rock underneath. And these hardened rock is essentially these cometary knots that we see in the helix.
The Hubble image reveals thousands of these cometary knots all pointing back toward the central star as if they were surrounding the star like a collar. Astronomers now conclude that the nebula isn't a bubble as once believed, but a coil-shaped cylinder pointing towards the Earth. Perhaps the key to how stars like our Sun die resides within this trillion-mile-long tunnel of glowing gases. Their shapes are deceiving. Donuts, rings, even an eye. What are these shapes? They are the beautifully diverse forms of planetary nebulae. About 1,000 planetary nebulae have been cataloged, each unique like snowflakes. Early observers viewed the night sky and saw these fuzzy disk shapes. They thought these fuzzy shapes were planets, so they called them planetary nebulae. These beautiful nebulae, however, have nothing to do with planets.
A planetary nebula is the gaseous nebula created by the death of a sun-like star. And when a sun-like star dies, it ejects its outer envelope, and the core of the star, which is really hot, makes the nebula glow. And this core will eventually become a white dwarf.
This glowing hot central core is a huge shell of expanding gas. As astronomers studied planetary nebulae, it was found that these shapes were more complex than previously thought. Were the differences due to how the gas shell evolved during expansion, the angle from which they are viewed, or do each form in a different way? Intrigued with these complex differences, a team of astronomers used the Hubble Space Telescope to explore the Helix Nebula. The Helix makes a wonderful candidate to study because it's so close to Earth that astronomers can study its intricate details. Its apparent viewing size covers a patch of sky almost the size of a full moon. Ground-based observations had shown a spoke-like pattern in the helix. The Hubble showed finger-like shapes along the inner edge. Each has a bright head and a long tail. Astronomers named them cometary knots. The team was so fascinated with the helix and its many intricate shapes that they pulled together data from many observations made by a variety of telescopes to get a clearer picture.
The Helix Nebula was interesting to us because it wasn't what we expected. What we expected was something much like my glasses here, where we'd have a rim and then we'd have a disc of material like the glass lens I have. And then what was interesting to us was that the glass would be tipped with respect to the rim. So in the Helix Nebula, the disk is tipped with respect to this ring.
Astronomers constructed a 3D model of the helix by combining the high resolution of the Hubble, ground-based images from Cerro Tololo Inter-American Observatory, and measurements from other telescopes that show the speed and direction in which the material is moving. In this model, we see two disks, an inner and outer, almost perpendicular to each other. Along the inner and outer disks are the cometary knots, or fingers. This enhanced image only leads to more riddles in the puzzle of how sun-like stars transform into beautiful sculptures in the sky known as planetary nebulae.